Alright, hello, welcome back. So in this video I'm going to talk about amortized loans. And an amortized loan, or an example of an amortized loan, is a home mortgage. That's the classical example. But so do car loans and in some cases student loans. Okay. Um, so an amortized loan is basically an ordinary annuity. There's some amount borrowed today and then that amount borrowed is going to be paid off in equal installments for a certain period of time, right? So in this case, in this example here, we have a family that takes out a 30-year mortgage of $260,000 to purchase a home today. The bank charges them a 7.556% annual interest rate. So starting next year, the family will make one payment each year for 30 years. So what's going to be their annual mortgage payment each year? Okay. Now we can solve this basically by using the PMT function in Excel. So we'll go to here, I have a little space there, we'll do equal sign, PMT, open parentheses. The rate that the family's charged is 0.07556, so we'll do comma. Number of periods, that's 30, comma. Present value, well, present value is just basically how much they borrow, so that's 260,000, comma. Future value, 0, type, well, it's an ordinary annuity, so 0. Close parentheses, and we get $22,134.65. So essentially, what's happening is, the family's going to have to pay this each year, right, to the bank as part of paying off they're going to have to pay this each year for 30 years as part of paying off, this $260,000 that they borrowed to buy a home. Okay. Now, in general, what's happening here is we're choosing some payment such that at this interest rate, if each of these payments are discounted to the present and then summed or added up, it would equal the present value or it would equal its present value rather would equal the amount borrowed, right? So just to check your work, you can kind of go over here and use the PV function, present value function. Again, 0.07556. That's the interest rate, 30-year period, payments, no future value, and then it's an ordinary annuity. And you'll see that we get 260,000, right? The amount borrowed, right? So that means we did everything properly. Okay. Now let's see. All right. So that's how most mortgages work, with the exception that most mortgages are actually payments are made monthly. They're not made on an annual basis. So a payment on the mortgage is made each month. What that means is that instead of 30 payments, there's actually, 12 times 30, right? Because they're 12 months per year, so that's going to be 360 payments. Some mortgages that are 15 years, that would be 12 times 15, right? And additionally, the annual interest rate in our previous example is 7.556%. That has to be converted to a periodic rate, and in this case, a periodic monthly rate, right? So we have to divide it by 12. But beyond that, right, the same thing is happening, right? We can use the PMT function again to find the payment. And of course, the payment's going to be smaller because it's a monthly payment. It's made every month, right? They're dividing it over many, many more periods. All right, so let's go ahead and find the monthly payment. I'll do equal sign, PMT, open parentheses. Oops, didn't mean to do that. PMT, open parentheses. This is a periodic rate. Now you can put in that 0.6297%, right? That's just 7.556% divided by 12. But you can also just go ahead and do the calculation within the function itself, like I'm doing here. See, I'm just taking the decimal form of 0.07556 and using the slash to divide it by 12. Okay. All right. Number of periods. Again, it's 360, but we know it's 12. I'll do Shift 8 to do the multiplication sign, and then 30, and then comma. PMT again, that's just how much borrowed, so that's 260,000. Comma, future value, no future value, and type is 0 because it's an ordinary annuity. Press enter, and we see that each month this family is going to pay $1,827.94, right? And they're going to do this over 30 years each month, right? So that's three. So they're going to make 360 of these payments over the entire life of the mortgage, right? So that means how much are they actually paying for this house overall, right? Including both the principal and the interest, right? So to do this, we would just take this, right? Since 360 of these are going to be paid, we're seeing that they're going to pay in total, ignore that, $658,057.71 over the entire life of their loan, right? So they're going to pay more, obviously more than principal, because some of this is interest. So if I go to this here, I want to make this positive, just, so I'm going to put a negative there. So basically, I just made that positive. It'll make the calculations easier. This is how much is being paid total. Only $260,000 of which is the actual amount borrowed, the principal. The rest is interest, right? So I can find the total amount interest. I take the total PMT, and then I subtract the principal, and that shows us that this family is going to be paying $398,057.71 in total interest. So they're going to be paying more in interest than they actually are, in principal, in the amount actually borrowed, about 50% more, to be specific. All right, so that's kind of the interest can be kind of tricky on or it can be sneaky, I should say, in terms of amortized loans. All right, so that'll do it for this one. You'll hear from me again.